In this video, we are looking at the concept of submodules. Before we even do anything, I want to make it clear that C++20 doesn't support the concept of nested modules, and what we are talking about here is like a hack. Let's look at an example here. Here we have a math module that we would like to set up, but this module is going to be made up of two submodules. We have the add submodule and we had the multi-div submodule. The first module is going to have functions to add and subtract, and the other one is going to have functions to multiply and divide. So you may have this kind of setup here, and you may want your users to have the ability to only import this part if it is what they need, or import this other part if it is what they need, or if they need everything, they can import the englobing math module. With C++20 modules, we have the ability to name our modules by using a dot. Please note that this dot doesn't have any semantic meaning, doesn't really mean anything. It is the same thing as if you had any other character in there, but we can use this hack to organize things a little bit better. This is the structure we will have in our project here. We will have a module named math, which is going to be englobing or bringing together other modules. And down below here, you see that we have an add submodule. This is the name. And we have a multi-div module. And the add submodule is going to have add and subtract. Multi-div is going to have multiply and divide. But if you only want to use this part here, you have the ability to only import it. If you want to use multi-div, you can import it only, but if you want everything, you can import the math module. And we achieve this by importing these so-called submodules here. This is the setup we are going for in this lecture here. Once you have these modules defined, you can head over to the main CPP file and import the entire thing if you need all the functions, or if you only need add sub, you can only import it. If you only need multi-div, you can only import it, and everything is going to really fall in place. Now that you know this, we can head over to our IDE and see this in action. Okay, here we are in our project. The project name is 48.9 submodules, and let's look at the GitHub repository and see what we have to deal with. So we have a set of files, we have the math module, and we have the submodule files that we will be importing in this math module here. We also have a main CPP file. If you go to the instructions here, you see we can follow these instructions to compile for the Visual C++ compiler on Windows. On GCC, we can follow these instructions, but on Clang, I want to draw your attention to the fact that the PCM files have to be named in a specific way. And if you break away from this convention, you will have problems that you will have to figure out a way to solve on your own. So the output PCM files should be named this way. You should specify the name of the module and say dot, okay, as we see here, and specify the name of the file .pcm. For example, the file is named addsub.ixx. After the dot, we will say add sub here. And you see that it is the same structure we follow for the multi-div PCM file here. This is something I figured out by reading the documentation and really reverse engineering the things I see in the documentation here. Make sure you follow this convention for this lecture. And if you happen to adapt this for other files, do remember this, otherwise you will have a bunch of problems. Now that we have this, we can create the files that we need in our IDE here. We need the math.ixx file. Let's create it. It is an interface file, so math.ixx. And the other one will be named add sub and multi-div. They will be interface files as well. So let's do that, create a new file. It's going to be an interface file as well. So add sub, and we need to add multi-div as well. Let's do that. An interface file, it's multi-div _div. And now that we have the files, we can copy the content from the GitHub repository. So let's start by the math module file, copy, and hop over into our IDE to the math file, remove everything and put in our code. Let's do add sub, and we copy and we bring that back in here, add sub, remove everything and put in our code, and we need to go back and do mult dev, and we can copy everything. Nothing special here, just a module defining a few functions. Mult dev, let's go there, remove everything and put this in place. And the rest is really the main CPP file that is going to be using those two modules, and we can copy and bring this in and remove whatever we have and put in the new code. This is now importing math, which is going to bring in both add sub and mult dev, but we can choose to import only either of these. Remember, this is a C++ 20 modules project, so we have to enable C++ 20. So let's go to properties, go to C and C++ language and enable C++ 20. After that, we go to general and enable scan sources from module dependencies. Let's say yes, apply, okay. And if we build, this is going to build our project. Notice the order things are built in. Take a moment to see and learn from this. And we can run this application now. Debug, start without debugging, and it is going to say whatever we say here. Now, we are using both add and mult. And we are able to do that because we imported the math module, which brings together the two so-called submodules that we have here. But if we only wanted to use the multiplication feature, for example, we could have only imported the multdiv submodule by just commenting out the parts that we don't need, commenting out the math module that we are importing here, and just importing multdiv, and this would have worked. If you build again, rebuild the solution, you will see things built up here. And if you debug, start without debugging, it is going to show you what we need here. We are just multiplying, we're not adding. This is something you can do if you really care about this. Let's turn this back to how it was and comment out this and import math because we want to compile this for other compilers. Rebuild, and let's import math. We are not importing that. Build again, and this time it is going to go through. And this is how you can use submodules in your C++ project. Remember that submodules are not really a language feature. This is just a hack to play on the names of the modules. And you can make many nested levels of these modules if you happen to need that. It is just a way to organize your code to allow users to only import the parts that they need. Now that you have used this IDE, let's hop over and see how to use the other compilers that we care about in this course here. We care about the G++ compiler, we care about the Clang compiler, and these are just the commands that you have to copy to paste into your terminal or PowerShell window to compile. Let's start with GCC, and we will start by compiling the IOStream header unit. It is going to go through. Let's copy the other command, which is going to compile our add sub module. So let's do that. We will compile the other sub module. Notice that we are following things that depend on others. And after that, we will do the math module because it depends on the other modules that we have pre-compiled before. This is something you should see and understand. Let's compile it. It is going to go through. And we can compile the rooster binary because everything is available now. If you do this and do ls, you will see your rooster binary down here. If you run it, it is going to say whatever it is the code says here. And this is how you compile using GCC. You can try and change the structure to only import this or that and recompile, but I leave that as an exercise to you. Now you know how to play with these things. Let's go back and clean up our mess. So ls and remove any object file, remove rooster, and remove the GCM folder. because we don't need that anymore. And we can hop over to our command prompt. We will be using Clang for that. So Clang, we compile the header unit. This must be becoming second nature to you now. This is done. Let's do the first submodule. We want the PCM file for that. Let's put in the command. Let's do the second PCM file. And we want to paste this in. This is going to go through. Let's grab the other command, which is going to be compiling the math PCM binary file. It is going to go through. Let's grab the other, which is going to put together our main object file. And we want to paste this in. It is going to go through. Let's grab the command to compile our submodules and modules into object files. We start by add sub, and the next one is going to be multi-dev, as you see here. Let's copy and paste it. We just copied, let's paste. And the next one is going to be the math object file that we want to compile. And we will put the command in here. And after that, we will use the Clang compiler to compile the Rooster binary, which is going to be putting together the object files that we have. At this point here, we have the math object file, we have the object files for the submodules, and we can combine all these things to create the Rooster binary here. Let's go back to our terminal and put in the command to generate the Rooster. If we do the IR, because we are in command prompt, we should have our Rooster binary. We can run it, and it is going to do whatever it is supposed to do. Now that we have done this, let's hop over to our Docker container and do ls. And we will be using Clang 18 to compile our code. And I am showing you all these things as options. You don't have to do them all. You can choose one compiler. It is going to be fine. And if later on you need another compiler, you can use the instructions in the README file to see how you can use it. Let's clean up our mess. Let's remove the object files, remove any PCM files, and remove the Rooster binary before we try using Clang. And we have the main files that make up our project. We have the submodules, we have the module, and we have the main CPP file, which is going to put everything together. Now we can grab the commands. We start by compiling the header unit. So let's copy and put that in place. We grab the command to compile add sub, the PCM file. Let's do that. Let's grab the command to compile the other submodule. We need to do that here, so let's put that in place. And we grab the other command. Okay, so let's put it in place. Again, notice the naming convention we are using for Clang. You say name and a dot and the name of the file. If you don't do this, you will have problems. And be careful about this. So let's put this in. And the next command is going to be to compile the main object file. Let's copy it and put that in place. And we need to compile the object files for our modules. We start by the add submodule file. So let's do that. We grab the other module, copy the code, the command, put that in place and paste. And we need to copy the command to compile the math module, put that in our terminal here, ignore these warnings, and we can put everything together to create our Rooster binary on Clang. So let's do that. And if we do ls-alh, we have our Rooster binary that you can see here. And if you run it, it is going to do whatever is needed here. This is really all I had to share in this video, showing you how to set up submodules. Submodules are not really a language feature. It is a hack we are doing to separate features into our modules and give users the ability to only import what they need. We don't have to force them to import the entire math module. If they only need add sub, it is what they can import and use it. If they only need multi-diff, they can only import that. But if they need everything, they have the option to import the entire math module. I am going to stop here in this video, and I will see you in the next one.